Okay, so it's just integration by parts. I just wanted to establish, is it important which one do we label as u and which ones do we label as v? Okay. Now, what we always want to try and think about is we want to think about how can we get rid of one of these by continuous differentiating or integrating, but differentiating. So I know that if I differentiate x, yeah, I know that actually just becomes 1. Yeah, which is nice because then that's quite easy to deal with. Now dv over dx, I'm going to call that as cos x, which means v is going to have to be sine of x because the integration of cos is sine. Now we use this formula just to substitute them in. So uv is going to be x sine x. I'm going to subtract by the integral of v, which is sine x, and du over dx, which is 1, so times 1, which is just sine x. And we know the integral of sine happens to be minus cos, so it's going to be x sine x plus cos x. Okay, because minus sine x and we're subtracting it, which makes it cos x. Okay. The next thing about it is, now I've made that a little bit smaller. I just want to think about, would it matter if I actually change my u and I change my dv over dx? So let's call u cos x and dv over dx equals x. Then I've got du over dx, so I need to differentiate cos, which will give me sine of x, and then if I integrate x, that means I'm going to make this half x squared. Okay, so let's substitute this into the formula. So I've got uv, which is cos x half x squared, and then that's going to be subtracted from the integral of v, which is half x squared, and du over dx is sine x. Now, obviously this is not the same, but maybe it might get to the same if you go a little bit further on. So I'm just going to look at this integral bit and see if I can integrate half x squared and sine x to sine x, just so I can be consistent with this, and then dv over dx I'm going to make into a half x squared. So I've got du over dx, which is going to equal to minus cos x, and dv over dx to give me my v. I'm going to have to integrate that. So I'm going to have to add 1 to make it 3, and then divide it by 3, which means my half becomes 6. Yeah, substitute into the formula again. So I've got uv, so I've got a sine x, 6 sine x, x cubed, minus the integral of v, which is 1/6 x cubed, and d over dx is cos x. And if you actually look at this, I'm just going to continuously, this cos is just going to keep going from sine cos, sine cos, sine cos, which isn't an issue. It's only an issue because this one here, all that's going to happen if I continuously integrate that is that my powers keep going to go up and up and up, and it's not going to get easier to integrate. Now, sometimes you can do something smart if this whole thing looks exactly like the question, but it's not. Okay, but we do have another strategy which we can do. So let's say we look at this last little bit of the integral, and let's say we swap it around now. So let's say that the u, I'm now going to call half x squared, and my dv over dx, I'm going to be calling sine x. Okay, my du over dx is just going to equal x, because I'm times it to make it into 1, and then I'm going to put dv over there. And then my v is actually just going to be cos x. Okay, essentially I'm just doing the opposite of what I've done before. Now if I substitute that into the formula, I'm going to be getting uv, which is half x squared cos x, okay, minus the integral of v, which is cos x, du over dx, which is x. And again, I've got something hard to integrate, but I can actually do something smart with this. So what I'm going to do is I'm actually going to write out the whole answer and my question. So my actual question was the integral of x cos x dx, which would equal my first bit, which is cos x half x squared, and minus like all of this. And so it's minus half x squared cos x, and because I'm subtracting, this minus becomes plus the integral of cos x x. So I should be writing dx, but I'm being lazy. Now, as you may notice, I've got cos half x and I've got cos half x. This cancels down to nothing. So I'm actually left with the integral of x cos x dx is the integral of x cos x dx, which of course they equal each other. We knew that to begin with. Yeah. So essentially, yeah, it does matter which way you go around. You can't do anything smart at the end. Just try and do it so you can focus on getting rid of like any of your variables.